Question 9. The first three terms of a geometric sequence are 3k plus 4, 12 minus 3k, k plus 16, where k is a constant. Part A, show that k satisfies the equation 3k squared minus 62k plus 40 is equal to 0. We know that in a geometric sequence, we are multiplying by a common ratio each time. So because we don't know what that common ratio is, we can call it y for now. So for part A, we can try and use this to make an equation in terms of y and k. So we can write this as 3k plus 4 multiplied by y gives us the next term, which is 12 minus 3k. We can also use it to make an equation for the second term and the third term, which would be 12 minus 3k multiplied by y would give us k plus 16. If we now make y the subject in both equations, we will have y is equal to 12 minus 3k over 3k plus 4. And for the second one, we will have y is equal to k plus 16 over 12 minus 3k. We can now solve this by equating both of these to each other because they're both equal to y. Therefore, we can write this as 12 minus 3k over 3k plus 4 is equal to k plus 16 over 12 minus 3k. In order to make these a linear equation, we can cross multiply, which would give us 12 minus 3k multiplied by 12 minus 3k is equal to k plus 16 multiplied by 3k plus 4. And if we now expand both the brackets on each side, for the first set of brackets, we will get 144 minus 72k plus 9k squared is equal to 3k squared plus 4k plus 48k plus 64. If we then bring all the terms onto the left-hand side, we have 9k take away 3k squared, which would give us 6k squared. We then have the k terms, which would be minus 72k take away 4k, take away 48k, which would give us minus 124k. And for the number terms, we have 144, and we would take away 64, and that would give us plus 80, and now this would be equal to 0. We can now simplify this quadratic equation by dividing everything by 2, and we would get 3k squared minus 62k plus 40 is equal to 0. And we have now shown that as required. For part B, we're then told that given the sequence converges, find the value of k, giving a reason for your answer. So for part B1, we are going to use the quadratic solver on the calculator to solve this by going to Menu, Equation. We select 2 for polynomial, degree 2 for quadratic, and the A term is 3. B will be minus 62, and C will be 40. And if we press equal, that gives us the first value, which is 20, and the second value, which is 2 over 3. Because we are told that the sequence converges, this means that the modulus of r has to be less than 1, which means that r would have to be between 1 and minus 1. Therefore, we now need to use each value of k to check which one will give us a value of r, which is between negative 1 and 1. So we can check first with k is equal to 20, and when k is equal to 20, if we substitute that into the sequence, 3 multiplied by 20 is 60, plus 4 would give us 64. 12 take away 3 times 20 would give us minus 48. And 20 plus 16 gives us 36. And in order to check what we have done to 64 to make it minus 48, we would do minus 48 divided by 64, and that gives us negative 3 over 4, which means that we have multiplied this by the negative 3 over 4, meaning that the common ratio r is equal to negative 3 over 4. When k is equal to 2 over 3, if we substitute k into each term of the sequence, 3 multiplied by 2 over 3 is 2, plus 4 gives us 6 as the first term. The second term would be 10, and the third term would be 16 2/3. So to check what we have done there, we would do 10 divided by 6, and that would give us 5/3, which means that the common ratio R is 5/3. So the value which is valid for this question would be K is equal to 20. And because the question has asked us to give us a reason for the answer, we will say that K is equal to 20 because when K is equal to 20, the ratio R is equal to -3/4, and the modulus of R is supposed to be less than 1. Part 2 of B says find the value of S infinity. For this part, we are going to use the formula for the sum to infinity, which is given in the formula booklet. And this is the formula that we are going to use. So for part B2, we are just going to substitute the values into that formula. So A is 64, as we found in part 1 of B. And the R is -3/4. And because we've got one takeaway -3/4, this becomes plus. And if we work that out on the calculator, this will give us a value of 256/7. And that is the final answer for part B2.